Welcome to The Explainer. Okay, today we are doing a super fast revision of Python, hitting all the core concepts you absolutely need to know, whether it's for an exam or your next big project. So let's dive right in. So before we even touch a line of code, let's step back and ask a really basic question. How do you actually talk to a computer? How do you take an idea from your head and get a machine which really only understands zeros and ones to get it? Well, the answer is, of course, a programming language. Think of it like a bridge. It connects our human way of thinking to how a machine operates. It's basically a set of structured rules that lets us give a computer crystal clear instructions. And that brings us right to Python. It's one of the most popular languages in the world for a really good reason. It's the engine behind everything from Instagram to the data science happening at NASA. So what's the big deal? What makes it the go-to language for so many people? Okay, let's get into what makes Python, well, Python. First off, its simplicity is a huge deal. The code is just easy to read and learn. It's what we call a high-level language, which just means you can write code that almost looks like plain English. Then, Python's interpreter does the heavy lifting, translating it for the computer in real time. Oh, and a super important thing to remember, it is case-sensitive. To Python, a little a and a big A are two totally different things. You gotta watch out for that. And you know what? Nothing shows off that simplicity better than the print command. Seriously, this is all it takes to get your first program up and running. You just type print, open some parentheses, and then put your text inside quotes. Bam! The computer spits it right out. It's like the classic hello world of programming, and it really is that straightforward. All right, so just like English or any other language you speak, Python has its own set of grammar rules. If we want to start building actual programs, we've got to learn its basic vocabulary and the rules for putting all those words together. And this here is the perfect way to think about it. In a human language, right, you have an alphabet that makes up words, and those words follow grammar rules to make sentences. It's the exact same idea in Python. You have characters that make up keywords and identifiers, and they have to follow the rules of syntax. Same principle, just a different language. So, the very first piece of grammar we need to nail down is the variable. The best way to picture a variable is just as a labeled box or a container. In this example, A equals 365. We've basically made a box, slapped the label A on it, and put the number 365 inside. Now, whenever our code mentions A, Python knows to go look inside that box and grab the value 365. But of course, you can't just name these containers whatever you want. There are rules. They have to start with a letter or an underscore. That's a big one. You can't use special symbols like the @ or a hashtag. And maybe most importantly, you can't use what are called keywords. These are special words like if or for that Python is already reserved for its own use. This just keeps the computer from getting confused. So what can we put in these boxes? Well, all sorts of things. Variables can hold different types of data. You've got your numbers, like whole numbers we call integers, or decimal numbers called floats. You've got text, which in programming we call strings. You can have an ordered collection of things in a list. And then there are booleans. These are super important. They are just true or false, and they are the foundation for making any kind of decision in your code. Okay, so we've got our data neatly stored in these containers, but programs aren't just about holding on to information, right? They're about doing something with it. And this is where things get interesting. This is where we learn how to build logic, how to make decisions, and how to repeat actions. We're about to turn our basic words into complex sentences. This right here, if, elif, else, is the heart of decision-making in Python. It works like a waterfall of logic. First, the program checks the if condition. If it's true, great, it runs that code. If it's not true, it moves on and checks the next elif condition. That stands for else if. And if none of those specific conditions are true, the else block is there as a fallback, a default action to take. What about repeating things? For that, we use loops. The for loop is your best friend when you know exactly how many times you need to do something. For instance, range 1, 6 tells Python to go through the numbers starting at 1, but, and this is a key detail, it stops before it hits 6. So what do you get? It prints out 1, 2, 3, 4, and 5. Now, a while loop can do a similar job, but it thinks about it differently. A while loop will just keep on going as long as some condition is true. In this case, we start I at 1, and the loop keeps running as long as I is less than 6. Inside the loop, it prints the number and then adds 1 to it. As soon as I hits 6, the condition isn't true anymore, and the loop stops. Okay, so we've learned the words and how to form sentences.
To write a proper program, we need to start organizing our data into, well, let's call them paragraphs. And we do that using Python's built-in data structures. This table is a fantastic summary of the big ones. The most important concept here is mutability. Basically, can you change it after you've made it? A list, for example, is mutable. It's perfect for something like a class roster where you might need to add or remove students. But a tuple and a string, they're immutable. Once they're created, they're set in stone. And finally, you have the dictionary, which lets you store information in key value pairs, kind of like a real dictionary. And yes, it's also mutable.
And this idea of immutability is a really, really big deal. Just like the quote says, once you create a string or a tuple, that's it. It's locked in. You can't just go in and change one letter of a string. You'd have to create a whole new string to replace the old one. This gives you a certain level of safety and predictability in your code that you don't always get with things like lists.
All right, we have flown through a ton of material in this little revision tour. So let's just take a breath and do a quick recap of all the essential tools we've just packed into your Python toolkit.
So, what have we got? We started with the absolute basics, variables for storing stuff and the different data types they can hold. Then we added operators for doing math and logic. We learned about control flow, using if-else to make decisions, and for and while loops to repeat actions. And finally, we saw how to organize our data with lists, tuples, and dictionaries. You get these down, and you have a solid grasp of Python's fundamentals.
So what's next? We've gone over the grammar, the vocabulary, the basic sentence structure. The only real question left is, what kind of conversations are you going to have with your computer? What are you going to build with this toolkit? And honestly, that's the most exciting part. That's where your real adventure begins.